Hi guys, welcome back to Nunley Math. I'm Aaron Nunley. Thank you for joining us for our new unit on the basics of geometry. The basics of geometry, if you've been following along with my class, you will know that we've just finished talking about algebra and applications of algebra, and we're going to find that a lot of the skills we learned in that algebra unit are going to come into play over the next several units, which would be the basics of geometry, then followed up with some two-dimensional geometry, some area, some perimeter, and then some surface area and volume problems. But this unit's going to act as a transition between those two units where we're going to talk about some fundamental ideas in geometry that are going to be important as we're moving along. A lot of definitions in here, a lot of terminology that my students are going to need to know. So I thought it'd be nice to get all this laid out right here at the very beginning before we dive in too deeply. So let's go ahead and hop right in here and get rolling. If you remember from our algebra applications unit, we talked about supplementary angles just a little bit. And supplementary angles are one of those things that are going to come up over and over and over again as we discuss geometry. So I wanted to make sure I redefined it here. Two angles are supplementary if the sum of their angle measures is 180 degrees. So for example, if I have a straight line, often referred to as a straight angle, we say that the degrees apart between this ray to the right and this ray to the left, we say if we're trying to measure how far spread apart those are, this would be 180 degrees. So if I were to take this long line right here and I were to cut it into two lines using this ray right here, I should say cut it into two smaller rays using this ray right here, you can see that this side should be 180 degrees as well. So when I cut that into two separate angles, I'm going to have a large angle over here on the left and a small angle over here on the right. And those two angles, when I put them together, have to add up to be 180 degrees. So if the smaller angle were 80 degrees, the larger angle would have to be 100 degrees because combined they have to equal 180 degrees. If the smaller angle were 70, then the larger angle would have to be 110 because together they have to equal 180 degrees. If the smaller angle was 60, the larger angle would have to be 120 because together they have to add up to be 180 degrees, which means if I did not know the size of the smaller angle and I were to call it x, I wouldn't necessarily know the size of the larger angle, but I would know that whatever it is, it's going to have to be 180 degrees, take away whatever is being used up for the smaller angle. Or I would call this 180 minus x degrees. And that's how we talk about supplementary angles. These two together have to add up to 180. If I know one, I can figure out the other by taking 180 minus the one I know. Likewise, when we talk about complementary angles, those are two angles whose angle measures add up to 90 degrees. You can see I have a large 90-degree angle right here. You can see this right angle symbol here in the middle tells me it's going to be a 90-degree angle, but I've taken that 90-degree angle and I've split it into two smaller angles. Those two angles together have to total 90 degrees, which means if this small angle was 10, the big one would have to be 90 minus 10 or 80. If the small one was 20, the big one would have to be 70 because 70 plus 20 equals 90, or 90 minus 20 equals 70, or for that matter, 90 minus 70 equals 20. 90 minus 30 would give us 60. And if I don't know the measure of the smaller one, I can't find the measure of the bigger one, but I do know whatever this is, this angle is going to have to be 90 minus that number, or 90 minus x. Complementary angles. That much is review from what we've talked about in previous lessons. When we talk about adjacent angles, two angles are adjacent if they have a common vertex and one common side, but they do not overlap. They have a common vertex, a common side, and they do not overlap. So, for example, if I were to talk about adjacent angles here, I would be saying, well, let's see, here's a vertex. This ray right here, or this side and this side together form this angle. This same side, along with this side, form this obtuse angle. Together, those are 180 degrees. They are side by side. They share this common side, we would say these two angles are adjacent. Now I want us to think about what happens when we have two lines that intersect when I look at the adjacent angles. Notice, if this first angle was 45, I know together with its adjacent angle, it's going to have to make 180 degrees. Or this angle and its adjacent angle are supplementary. We learned that term over here. They are side by side. Together they have to make a straight line. I can use what I learned about supplementary angles to figure out the measure of this angle. Do you know what it is? Well, let's see. If the whole thing's 180, this much is 45. 180 minus 45 tells me that this must be a 135 degree angle, because 135 degrees combined with 45 degrees makes my 180. But there's a lot of other cool things that are happening here as well, because you'll notice this line right here that I'm tracing with my arrow is also a straight line. That means if I were to take this angle right here, this one right here in the top left, and this angle in the bottom left, those are adjacent angles that are supplementary as well. They're side by side, and they share this side. If this bigger angle is 135, how big would the smaller angle be? Well, I'd subtract again. 180 is the whole thing. This first piece is 135, meaning the smaller piece is 45 degrees. But guess what? This angle right here, this is a straight line, which means an angle measuring from here around to here also has to be 180 degrees. If I know the smaller angle here is 45, what does that make this bigger angle? Well, it's 180 minus 45, which is 135. Now, I've got a lot of arrows going on in there, and I've got a lot of computation. Let me rewrite this with just the answers. If this first angle was 45 degrees, we said that the adjacent angle over here, the one that's side by side and shares this side, is going to be 135 degrees. These are supplementary. If this larger angle is 135, we said this smaller angle would have to be 45. And if that smaller angle is 45, we said this bigger angle over here has to be 135. Do you notice anything interesting or helpful or useful about that? You should see two things. Number one, when you have two lines that intersect, you are going to get supplementary angles when you look at the things that are adjacent to one another, side by side. No matter which pair of adjacent angles you pick, you're going to add up to 180 degrees. That comes from this definition of what it takes to make a straight line. The second thing you should notice is that the angles that are across from each other, right here and right here, are both the same measure. This is 45 and this is 45. This is 135, this is 135. And this is going to happen every time you have two lines that intersect one another. You're going to get adjacent angles that are supplementary, and you're going to get angles that are across from each other. We call those vertical angles that are congruent. And that's pretty cool, because if I were to draw a picture like this and tell you that this acute angle, this small angle is 50, you can use this small angle to figure out the measures of all the other angles. This big one right next to it has to be supplementary to it, meaning it has to add up to 180, so that would make a 130. Well, of course, this one over here is 130 as well, and the one across from it is going to be a 50. There you go. You get 130, 50, 130, 50. Notice as you go around, supplementary, 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 supplementary. If you go diagonal across, you get 50, 50, and 130, 130. They are congruent. Can you find the three missing angles in this picture? I'm going to recommend that you pause the video, try that one on your own real quick. I'm going to assume you've done that. Hopefully you realize that since these have to add up to 180, this is a 150. Since these have to add up to 180, this one's a 30. And since these have to add up to 180, this is a 150 as well. I got one more. Pause the video, try this on your own. Hopefully you've done that and realized this top one has to be a 40 because these need to make 180. If this is 40, that means the one over here is 140. And if this is 140, that makes this a 40. Adjacent angles are supplementary. The vertical angles, or the angles that are across from each other, are congruent. It's kind of cool, right? So here's what we can do with that. If I were to give you two lines that intersect and tell you that this is 45 degrees, I automatically know the other three angles. Notice that 45 and 45 are the same measure. 135 and 135 are the same measure. We call those vertical angles. Notice the two 135s do not share any common side. This does not border both. 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 The only point they have in common is that vertex or point of intersection right there in the middle. Vertical angles will share a common vertex like this, but they will not share common sides. What that means, though, is every time I have two lines that cross, if I know one, it's very easy for me to figure out the other. If I know one, it's very easy for me to figure out the other. Those are vertical angles. All of this is done just by having two lines that intersect. Now, there are lots of patterns like this that exist. For example, we know about the interior angles of triangles. We say the sum of the interior angles of a triangle are always 180 degrees. 50 plus 60 plus 70 is 180 degrees. Not too bad, right? But what if I were to ask you about the reflex angle on the exterior of the triangle? Can we figure that out? Well, we can if we remember that circles always have 360 degrees. If I were to go all the way around, it's 360. If this much is 50, how much is left for the reflex angle on the outside? Well, it's going to be 310. It's 360 minus the 50 inside. How about this? This is a 70. What's the reflex angle? Well, 360 degrees, take away the 70 we have already got, means there's 290 left over. How about this last one? You've probably figured this one out already. 360, take away the 60 that are on the inside, leaves us with 300 that are on the outside. And we could take all these different patterns and relationships and we create all kind of cool geometry problems and situations from them. We can use this to figure out a lot of information when it's not given to us in the original problem. There are all kind of problems that we can solve using the information we just talked about. This is a simple example that comes out of an old textbook. Notice I've given you one angle. You should be able to figure out all the others. I'd recommend pausing the video and trying to find those on your own. If you're struggling, certainly you can turn on the video and watch me do it. I'm going to fill these in, not necessarily in order. Let's see which one I got first. I put that this was 76. I knew that because these are vertical angles. They're directly across from one another. How about the other ones? Well, let's see. These are side by side. They share the common side. They're adjacent angles. Adjacent angles, so they're 180 minus 76. This is going to be 104. And if this one's 104, I already know this has to be a 104 as well. Can you do this one on your own? Again, I'm going to recommend you pause the video, try it, and then restart to see if what you did matched what I did. I've got that these two angles are vertical, therefore they're both 55. I've got that if this is 55 and this together with the second or larger angle makes a 180, I know that has to be a 125. I can figure out all four. And I can make these more fun and interesting if I want to. Can you figure out the measure of angle X? No? Maybe? Well, take a look at this. If I were to highlight or make these red, notice that 110 is the measure of this large angle, which means the vertical angle across from it must also be 110. Well, you can see this 110 is divided into two smaller angles, one of which is 30, which means the other one must be 80. Not too bad, right? Remember, we're just using these same simple rules about lines crossing, making vertical angles and adjacent angles. Well, if this is 110, can we figure out what the one right next to it's going to be? Altogether, they've got to make 180. Means that has to be a 70. And that means the vertical angle across from it is a 70 as well. Here again, I'm just splitting things into pieces, looking for things that I can recognize. Here's another one. It's a similar kind of problem. I'd recommend pausing the video, trying it on your own, and then watching me do it. Let's see. As I work my way through it, I'm going to take a look at this line and this line. Feel free with your pencil on your paper to highlight and draw as well. I find that to be very useful in trying to see things because I can look here and say, oh, well, this is 40. This is vertical. That means it's 40 as well. What else can I see? How about this? I know that this is a straight line, which means if this is 40, this must be supplementary. It must be 140. Well, if this angle is 140, that means this angle must be 140 as well, because they are vertical to one another. And this 140 is split up into a 25 and a 115. I think these are a lot of fun. To me, this is like solving the puzzle. Can you do these? Any ideas? If I have a 69-degree angle here on the inside of a triangle, any idea what this x would be out here? Well, of course, it's 111 because these have to make a 180. How about up here? If this interior angle is a 95, any idea how big this exterior angle is? How about 95? Because together they have to make a 180. Notice, by the way, that this picture does make a triangle. I mentioned that because it's kind of difficult to figure out what z is out here all by itself. But if I already know two angles inside my triangle, I should be able to figure this angle out pretty easily. Do you remember how? Hopefully you remember that every triangle has 180 degrees in it, which means the two that I already have total 154, leaving me with 26 degrees for that last angle. And once I know this is 26, I can figure out this side because together they make this straight line. This is 154 degrees. Now I've got one more of these, so I'm going to go ahead and put it up here. I'm going to again recommend that you pause the video and see if you can find these four missing angles on your own. Notice that this time I gave you the exterior on a couple of them. Once you think you've figured those out, go ahead and restart the video. Let's see if you've done the same thing that I've done. Notice that this is 305, but a full circle is 360. That means the interior must be 55. If a full circle is 360 and this much is 265, that should tell you that the inside is 95. If these two angles are 55 and 95, notice you have a triangle. Triangles always have 180 degrees. What you have already is 150. 180 minus 150 is 30 degrees. And once you know the 30, you should realize that together these have to make a 180, which means this is 150. One thing I should point out, notice that it does not make sense that this is a 95-degree angle. This is just a set of numbers that I made up. You'll find a lot of times that your pictures will not necessarily be drawn to scale. This was intended just to be some kind of a generic triangle, and then we just plug some numbers in. Don't go by how it looks. A lot of students will say, well, I think it's about 50 degrees because it looks like it. That's really not very useful in textbooks because they often will use generic triangles that are not drawn exactly as they should be. So make sure you're using the numbers that you are given. Tell you what I'm going to do. I'm going to go ahead and pause here. I'm going to stop this video. I'm going to split this into two videos because I think this is getting just a little bit on the long side. Thank you so much for watching. Make sure you check out the second half of this video here in just a moment. I'm going to go ahead and put that together for you. Make sure you check it out. Also, make sure you give us a big old thumbs up. Let us know you're out there watching. And certainly, if you've not rung that bell to turn on your notifications, make sure you do that for us as well. That would be greatly appreciated. All right? You guys take care of yourselves. I'll talk to you later. Bye-bye.